Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the adiabatic free expansion. So you can see that in this arrangement, there is a cylinder in which there is a movable piston, and on the left side of this piston, there is a gas. We can say that it is a ideal gas, and on the right side of this piston, there is vacuum. Now we have removed this pin which was initially acting as a stopper for this piston. So as soon as we will remove this pin, this piston will start to move towards the vacuum due to the pressure of the gas. And as there is vacuum on the right side of the cylinder, so there is no resisting force acting on the piston which is resisting this piston to move towards right side. So we can say that this is a free expansion because this piston is moving against nothing. So first of all, adiabatic free expansion is the process in which obviously delta Q is 0 because this is a adiabatic process, and this is a expansion process. So this is a expansion process. So delta V is positive, volume increases, and the work done is 0 obviously because whenever we say that gas has performed this amount of work done, then always we say that work done against surrounding is dW, but there is no surrounding near this around this piston which would restrict this piston to move. Therefore, against the vacuum, the work done by the gas in moving this piston would be 0. And obviously, therefore, delta U will be 0 because dQ is equal to du plus dW. Okay, so temperature will remain constant in this case because delta U is 0, and by PV is equal to nRT, we can say that if V increases, PV is equal to constant as temperature remains constant. So pressure decreases and volume increases. So this is a adiabatic free expansion process. Now let us see that what happens when this ideal gas is expanded freely against vacuum, and what happens when a real gas is expanded freely against the vacuum. And the question is the fact that when an ideal gas is expanded freely, then it does not get cooled down, but real gas cools down during free expansion. Explain why. So first of all, let us talk about the real gas. We know that between the molecules of a real gas there is a force which is a attractive force, intermolecular force, and when this piston is allowed to move towards the vacuum, then obviously we know that dQ will be 0 and du plus dW will be equal to 0, and therefore you can see that when this piston will move towards this side, and we know that for real gases this du is duk plus dup plus dw is the work done against surroundings, so that is 0. And we also know that the work done against surroundings is 0, so we can say that duk plus dup is 0 in the case of real gas. Now if we allow this piston to move towards the vacuum, then we can say that the distance between these molecules will increase, and therefore the potential energy of this system will increase. So dup will be positive. Okay, it is just like there is a spring in which there is attractive force, and you are trying to move away these blocks from each other against the attractive force. So you are doing some work against this intermolecular force, and that work done is stored in the form of potential energy. So potential energy of this system would be positive. But in this case we have not done any work. In fact, if dup is positive, then duk will be negative because their sum is 0. So we can say that the internal kinetic energy of the gaseous molecules of this real gas will decrease, and therefore temperature of the real gas will decrease. T of the real gas will decrease, and hence real gas will cool down. But in the case of ideal gas, dup is 0 because intermolecular forces is not present between the molecules of an ideal gas. Therefore, we can say that dq is equal to duk plus dw, and all of them are 0. In fact, first of all, let us say that dq is 0. Then we can say that dw is 0 in free expansion, and hence duk will be 0. Therefore, the temperature of the ideal gas will remain constant. Okay, so this is the reason why the ideal gas does not cools down during the free expansion, while the real gas cools down at the time of free expansion. Now let us also take a new conceptual example. That let us suppose that there is a container that has a gas that contains positively charged ions, and there is no intermolecular force apart from the electrostatic force between the ions, and this gas is being allowed to expand freely. Then what we can say about the temperature of the gas? So again we know that as the ions are positively charged and they are like charged, so they would be naturally repelling each other, and if we allowed the gas to expand, then the intermolecular distance between these two ions will increase. Hence the work done by their F, or we can say that we know that electrostatic potential energy is kq square by r. So you can see that r, intermolecular distance between the two ions, increases, and hence work done by F is positive, and therefore u, delta u, will be negative. So we can say that u final in this case will be kq square by r2, and as you can see r2 is greater than r1, therefore we can say that the internal potential energy of this system will increase. Now again, as this is not an ideal gas because there is intermolecular forces present in the molecules, but this force is repulsive in this case, so we can say that dq will be again equal to duk plus dup plus dw, and dq will be 0, as well as du, work done against surroundings, will be 0. So we can say that dup plus duk in this case would be 0. So dup will be equal to minus of duk, and we have already concluded that the potential energy will decrease. Therefore duk, or let us use an next page, dup is equal to minus of duk, and we have already concluded that dup will be negative, so duk will be positive. So therefore we can say that temperature of the gas will increase, or we can also theoretically check this fact that when we will allow them to go far away because they are naturally repelling each other, then their potential energy will be released, and as this energy cannot go outside this system, therefore this energy will increase the temperature of the gas. So we can say that the temperature of the gas will increase. So this was the complete analysis of free expansion along with the two examples. So in the next video I'll be bringing more concepts of thermodynamics. Thank you.